Morning biology. Hey, I hope you had a great spring break and we're going to get some notes done today. Sorry I can't be here today, but I will see you tomorrow. So today is just like another day, just an everyday. Same expectations are here in my classroom for direct instruction, just like you have every single day. So you need the food chains and food webs note sheet out in front of you. That's what we're going to take care of today, and hopefully it's going to go easy breezy and straightforward because it's probably going to be reviewed to you. But you are still going to give everybody the same respect and the same expectations that I normally have here in my classroom. So let's remember, you're going to be silent during this whole time, okay? No other conversations. You're going to raise your hand if you need something, and our wonderful sub today will come and help you out. She's awesome. Note taking. You're taking notes. That is what you are supposed to be doing. You're going to be writing what I'm writing. And then at the end of the class period, you are going to turn in that note sheet with your name on it, and that is going to be the record that you did something today. Okay? Not tomorrow. I don't want to see it turned into me tomorrow. You're going to turn it into the sub today. Did you hear that from my mouth? Yes, I hope you did. All right. So you are going to stay seated. No bathroom breaks while we are doing direct instruction. All right, that's a normal thing here in this class. Active participation means your head is up. It's not on the desk. We're not sleeping today. And you're facing the teacher, which is me. Hello. I'm here on the screen. And no electronics. I don't want to hear about phones being out, okay? You don't need your phone for this lesson. No laptop, no earbuds, all right? So go ahead and take care of this right now. I'll wait, because I know a couple of you need to do this. All right, everything off your desk? Everything ready to go? All right, let's go. So we're talking about food chains and food webs. There are 3 types of organisms found in our food chains and food webs. You are filling in these blanks, okay? So we've got autotrophs, which are our producers, okay? Heterotrophs, which are our consumers, and we've got decomposers, all right? So we're going to fit them into these 3 categories. Autotrophs, or producers. These are organisms that make their own food, either using light energy for photosynthesis, we remember about that, or chemical energy for chemosynthesis. Ooh, that's something we haven't talked about before. We'll talk about that a little bit more tomorrow. They are the start of every food chain, okay? So emphasize that. They're the start of every food chain. So producers, these are mostly plants, right? Here's our flower, okay? But we also have chemosynthesis. So that could be something happening with bacteria. That could be a producer as well. So we'll talk about that a little bit more tomorrow. Heterotrophs, or consumers. A heterotroph means that it cannot make its own food. Remember, hetero means different. Okay, so we're going to have it has to have a different kind of eating, all right? We're getting energy from something different. So we're consuming something. We are heterotrophs. Organisms that consume or eat other organisms to get chemical energy. Okay, as they cannot make their own. All right, so autotrophs, see, it's automatic. They make their own food, okay? Heterotrophs, it's not automatic. They have to get it from something outside of them, all right? All animals are consumers. All right, pretty easy so far, right? All right, not bad. So, decomposers. Let's check these out. Decomposers are organisms that break down organisms. Break down, not just any kind of organism, they break down dead organisms, okay, and organic matter to obtain chemical energy. In this process, oh, there's your bell today. I kind of like it. Hope you like it too. All right. In this process, they recycle nutrients. All right. So a good example for a decomposer would be fungus. Okay? Fungi and some bacteria are decomposers. Okay, so think about molds. Think about if you have bread that's left out for too long on the counter. This happens to me all the time. We don't use all of our bread in the package, and then we go and try to make a sandwich, and oops, it's got some mold on it. It's got something blue on it, all right? That's fungus that's trying to break it down because it's using it for food, all right? That's a mold, all right? That's just the part of a decomposition process. If we left that bread out on the ground somewhere or in a compost bin, then all sorts of decomposers would break it down into its components, and those nutrients would go back into the soil, and that's the part of our cycling process that we're going to talk about here in a little bit. All right, so, oh, my daughter wants to come and say hi. Say hi. Hi. Okay, this is one of the reasons why I am out today. All right. So
wait, what is
this? Is a pen for me to draw. Hey, why don't you go and draw over there? And I am going to finish my lesson. Okay? Say bye.
I want to drink.
Well, maybe in a little bit. Go on. Go. All right. So, let's talk about a food chain. We've got an example of a food chain down here at the bottom of your slide, all right? So when you have a food chain, you are showing the flow of energy between these organisms, okay? So a lot of times people think food chain just means, oh, this animal eats this animal eats this one eats this, and yes, that is what's happening. But what's really going on is we have arrows right here, and they're showing the flow of energy. Oop, let's move me so that I'm not blocking you. All right, there you go. So now, this is showing the flow of energy from the grass at the start all the way up through the fox, okay? Because every time something gets eaten, its energy goes to the next level, all right? So we'll start here with grasses. Grasses, we're going to identify the type of organism that each of these examples are. So a grass is a producer. Mainly because it's a plant, it does photosynthesis, and it makes its own food. So really, where does the grass get its energy from? It doesn't just come from nowhere. It gets its energy from the sun, okay? So the sun provides energy, so we should have kind of another arrow this way. Sun provides energy to the producer, the grass, which then gets eaten by the vole. I I hope that this is not a new animal to y'all. Voles are kind of like moles. They burrow. They have these really big teeth. My dog liked to chase after voles in the backyard, and when she would catch one, it would squeak. It would make this really weird sound. So if a vole eats grass, then that means it gets its energy from something else. So we can identify it as a consumer, okay? So it's a consumer. And it is the first consumer in this chain, right? It's the first one. So it is the primary consumer. All right. So primary consumer. And we can also call this an herbivore because it only eats plants, right? It's not going to eat anything else. The only thing that it's going to eat will be the level directly below it. All right. Then the weasel is going to eat the vole. Poor vole. Okay. So the weasel's going to eat it. The weasel also gets its energy from consuming something else. So it is a consumer. Okay. And it is the second consumer in this chain. So we call it the secondary. Consumer. Okay, and what does he eat? Well, he eats the vole, which is not a plant. Okay, so the weasel is a carnivore. He eats meat, right? Okay, so finally the fox. The fox is also, fox doesn't make its own food. It's the same thing. It is a consumer. And what kind of consumer is it? Primary, secondary. We call the third level the tertiary consumer. Okay? Fox is also a carnivore. All right? So, basically what you should know from this is your names of your different levels. Okay? The direction that the arrows are going to point. The arrow is not going to point toward what each one eats. It's going to point in the direction of energy flow. All right? So make sure to note that. The arrows show the flow of energy. Okay, so the grasses, the amount of energy that the grass produces from the sun gets transferred up to the vole, which then consumes it, and some of that energy gets transferred to the weasel when it consumes it, and some of that energy gets transferred to the fox when it consumes it. All right, so there's your quick little review of a food chain and your different organisms. All right? So let's move on to the next part here. All right. Now we've got energy pyramids and trophic levels. I'm going to move myself down for a moment. Okay. So in relation to this, we can show how much energy is transferred up each level by the diagram of a trophic pyramid. All right, so our food chains, let's fill in our blanks first. Our food chains can be arranged in energy pyramids. These have different levels called trophic levels. Basically, trophic just means feeding, okay? So when you think of autotroph, it's self-feeding, okay? So these are feeding levels. Most food chains are limited to 4 or 5 trophic levels. This is because the flow of energy between trophic levels is inefficient. Here we go. Okay, so this all relates to the laws of thermodynamics. Okay, now I'm not going to get into chemistry and physics for you, but if you want a scientific explanation for why all of this happens, it's all related to the laws of thermodynamics. Okay, energy cannot be created or destroyed. It just gets transferred to another form. So we're going to prove this in just a minute. In fact, only around 10% of energy stored as biomass in one trophic level ends up as biomass in the next trophic level. And when we're talking about one trophic level and then the next, we're talking about going up the pyramid, okay? So we start at the bottom and then we say the next one, it goes up, is the one right on top of it. Then the next one after that is on top of that one. We always go up, all right? Always go up. So the 10% of energy stored as biomass in one trophic level, that's the only amount that's going to be going up. So this is known as the 10% energy transfer rule, okay? So this is important, okay? I'm circling it. I'm putting arrows by it. You need to know this. Absolutely, okay? So we're going to complete the missing numbers to show this rule, all right? Here we go. Let's take a look. Let's start down at the bottom here. So we've got 10,000 kilocalories of energy down here at the bottom, all right? That's where we're going to start. Now, going up to the next trophic level means we're going up to this one right here at the primary consumers. So producers produce 10,000 kilocalories of energy. If that is true, primary consumers, when they eat, the producers are only going to have how much energy? Okay, so 10% is going to be transfer. So what's 10% of 10,000? 1,000. Okay, so you just take a 0 off. It's really as easy as that. Okay, take a 0 off of the end, and then you got it. So let's try it up here. Secondary consumers, when they consume their primary consumers, how many kilocalories of energy are we going to have at this level? Let's take off a 0. 100. 100 is 10% of 1,000. All right? And then finally, up at the top, tertiary consumers, when they consume the secondary consumers, they're left with only 10 kilocalories of that original 10,000. So being up at the top of the trophic pyramid, it means you're a top predator. You've got pretty much all the power. You are going to be able to eat stuff from all over the place. Nothing's going to be able to get to you. All right. However, if only 10 kilocalories are being transferred to you for every secondary consumer that you eat, what's going to happen? You're going to need to eat a whole lot more than somebody at the lower level. All right? You have to eat a whole lot more. So if tertiary consumers were able to eat producers, then they'd get a whole lot more energy. But there are a whole lot of tertiary consumers that are omnivores and are able to eat both meat and plants. Fortunately, we are. So that's a good thing. All right. So let's make sure that we have everything filled in here. All right. I'm going to move myself so that we get this. All right. So tertiary consumers are our top consumers. Those are our predators. Secondary consumers, those could be anything like, here I'm going to write some examples in here. How about, how about fox? Okay, fox could be a secondary consumer, or a what about a primary consumer? We've got rabbits. Okay. A snake. Okay, could be a secondary consumer. A lot of these can switch between primary and secondary also, okay? Producers, you've got all sorts of stuff. Grass, trees, flowers, right? Okay, other primary consumers, maybe some insects, right? So make sure you have some good examples in your head of each one of these levels. Okay, so let's talk about this right here. All right, got all these arrows coming off of the levels. So we said that we start at 10,000 kilocalories and we end up with 1,000 up at this level. But I just said earlier that energy cannot be created or destroyed. So if it's not being destroyed, then where's it going? This is what's happening, okay? It's being lost. It's being lost to the environment. So we're going to explain that over here to the side. Most energy is lost as heat, which is produced during cellular respiration. Okay? Because all of these organisms do cellular respiration. Remember, even plants do cellular respiration. They do photosynthesis and cellular respiration. So some energy is also lost when an organism dies without being eaten, and when parts of an organism are either not eaten or are not digested. So, like bones, it's really hard to digest bones. But those are still parts of bodies. So when that happens, then some of that energy is lost. And we also have this part over here, which are our decomposers and detritivores. And those take up some of that loss as well, because they decompose those extra dead bodies and that material that would otherwise just be laying around and doing nothing, contributing nothing to the environment. Instead, it's broken down into its natural components, and the nutrients go back into our cycles. Okay, we've got our front page done. Let's head on to the back. Flip this over. All right, so we're going to do an example of a food web. All right. It shows all of the food chains in one ecosystem. So the difference between this and a food chain is that a food chain is linear, okay? It shows one direction of energy flow. So just this eats this, this eats this, this eats this, and energy is flowing in one direction, all right? Well, a food web shows multiple different examples of where that energy can go. So let's take a look at this. Rabbits, mice, and grasshoppers all eat grass, okay? So we're going to start with grass, and we say rabbit eats the grass. So what direction is my arrow going to go? Toward the grass or to the rabbit? Do you remember? If the grass is eaten by the rabbit, then the energy is going toward the rabbit, okay? So what else eats grass? Mice and grasshoppers. Okay, so right now we've got 3 different food chains started. All right, so we got that. Rabbits are the prey of owls, foxes, and hawks. Okay, so owls eat rabbits. Okay, foxes eat rabbits, and hawks eat rabbits. There you go. All right, because the rabbit's energy is going to be transferred to those. All right. Grasshoppers are the prey of frogs and birds. All right, we've got grasshoppers. Oh, we're going to get something to drink in just a minute. I'm almost done.
Wait.
Yep. Aren't we almost done,
This
class? Yes, we're almost done.
connects to this.
It does. It connects to that.
I.
Hey, go and draw some more real fast, okay?
No.
Okay. Yep. Go. Because mommy's teaching right now. All right?
So grasshoppers.
Wait.
Grass.
Here, you want to listen to this? Here, we've got grasshoppers are the prey of frogs and birds. So grasshoppers get eaten by the frogs and the birds. Okay, so we draw the lines to those. All right. Next, foxes and owls are predators of mice. So we've got foxes and owls are going to eat the mice. Okay, remember? So the mouse gets eaten by the owl, and the mouse gets eaten by the fox.
Wait,
Okay.
what is grasses?
Grasses, yep. All right,
Get killed by the mouse?
yep.
Wait, what about the snake?
Oh, we're gonna add in the snake right now. Birds and frogs are eaten by owls and snakes. Okay, so birds and frogs are both eaten by owls and snakes. So we're starting with the bird. Bird's eaten by a snake, and it's eaten by an owl. Frog is eaten by a snake, and frog is eaten by an owl. Whoa, okay? Hawks hunt snakes from the sky. So snakes get eaten by the hawk. Whoa. Okay, so this is a food web, all right?
Can I have the pen?
Nope, can't have the pen, but you can go and play on Abby's phone, all right?
Yay.
There you go. So, we're going to take a look at why this is a bunch of different food chains now. So one thing that I want to point out to you about this, let's make this a different color. Color. Okay, so just because this got a little bit crazy in here, all right? Our grasses are the producers. That's level 1, right? Rabbits, mice, grasshoppers, those are all consumers. Those are level 2, okay? All sorts of things. So you see how I'm labeling these? That's what you're going to do here in a minute. You don't have to color them in. I want you to label them 1, 2, 3. This could be a 3, right? And 4. Hawk would be a 4. All right? So the different trophic levels. That's what you're going to do at the very end here. All right? Because here, if we take a look at this, our hawk is really the only one that is a 4th level consumer. But we have multiple tertiary consumers, we have multiple secondary consumers, and we have 1 primary consumer. Now, what's the other thing that we should add in here? Grasses, where do they get their energy from? The sun. So where does really everything get its energy from ultimately? the sun. Okay? There you go. Okay, last thing. Let's take a look down at the bottom. All right. So, I'm going to put myself right up above this food web key because you're now going to change that in a minute. All right. So, in this box, what do you call? We're going to name each type of animal and give an example from the food web. So, an animal that hunts and kills other animals for food. So, take a look at your food web. If it hunts and kills another animal, then that's going to be a predator. Okay? And an example from your food web. Okay? You have multiple examples, but something that hunts and kills. Okay? Is that going to be a producer? No. All right? It's not going to be a producer. So it could be anything above a producer level that is going to hunt and kill. Probably not a primary consumer. Probably up above the secondary consumer and above, okay? But it could be even a frog, okay? That would be fine. An animal that only eats plants. Animal that only eats plants is an herbivore, okay? Herbivore, so an example would be a primary consumer, right? So you can choose any of those primary consumers. Let's do grasshopper. But you can choose any of them. All right, an animal that is at the top of a food chain, okay? So that is an apex or a top predator. Okay, example, what's the highest one? What's the only one that's a number 4? Oh, that's a hawk. Animal that only eats meat. That's going to be a carnivore. All right, so that could be, let's see, example, any of your secondary consumers, tertiary consumers, something like that. Let's do the fox. Okay. An animal that eats both meat and plants, okay? It's not going to be on your food chain or food web. So let's think of one. An omnivore. Okay. We are omnivores. Well, we are made to be able to eat both plants and meats. Some of us choose not to. Up to you. But an animal that could eat both plants and meat would be like a pig. Okay. Animal that eats animals killed by other species. This is a scavenger. Okay, so if you see circling birds up above roadkill sometimes when you're on a road trip, then yes, those are scavengers. Some people think that the Tyrannosaurus Rex was a scavenger also. Who knows? Maybe we'll find out one day. All right, so an example of this could be a vulture. Okay, so let's take a look over here at our impact of species loss. If a population of species is lost from an ecosystem, so look back, I'm gonna switch back real fast. Look back over here. If we lose one of these, let's say we took the, let's say we took the mouse. Okay, you don't have to draw this. I'm just saying, let's take the mouse out of our food web, okay? What's going to happen to the rest of the food web? Okay, Well, the owl is going to lose some of its food. The fox is going to lose some of its food, and the grasses are going to lose something that eats them also. Okay, so there's going to be impacts on all different levels. What if we lost the grass? Well, that's going to impact the whole food chain. Everything's going to go down. Okay, it crashes, it collapses. This is what I want you to know. So if a population of a species is lost from an ecosystem, it can have devastating consequences. If there are other species that depend on it as a food source, like the owl with the mouse, their numbers can decrease rapidly. This has a knock-on effect on the entire ecosystem. So basically, it's going to be a chain reaction. Okay, so when one species decreases or is gone, another species is going to decrease, another species is going to decrease, and it's a cascade. That's what we call a trophic cascade. Here we go. Ready? Trophic cascade. Cascade effect. One leads to another. So this is what you need to know about ecosystems right now. So what I want you to do with your food web, before you turn this in, before you put your name on it and turn it in here, I want you to, you can do this with colors if you want, if you have colors, or you can just do this with numbers. Ready? Right here with your food web. Producer is number 1. Primary consumer is number 2. Secondary consumer is number 3. Tertiary consumer is number 4. And quaternary consumer is number 5. Okay, so that may be a little bit different than what I numbered everything up at the top. Okay, so I may have numbered the hawk a little bit differently or something like that. But I want you to use this system right here to number the different levels, the trophic levels of your food web. Every single organism has a number, all right? Every single organism. So do this on your food web. Make sure it's all filled in, put your name on it, and turn it into the sub. And that's what you have to do today. Okay, so thanks so much, biology. I will see you tomorrow. Have a good day.